Okay. Good evening, everybody. How's everyone doing tonight? Everybody's doing well. How's it going, Chewy? Mr. Wizzix, welcome in. Sorry for the light over this way. It's going to shine in one way or the other because that's where the sun's rolling now. I may have to see about getting a sheet or something to cover that window up for streaming. How's everybody doing today? Hey, Timor, welcome in. Welcome in. Hope everybody's having a great day and a great week so far. It's been, it hasn't been too bad. It's been busy. Not too bad. I think Thursday it's really going to set in when we go and do the going away lunch for my one guy that's getting ready to leave, because that's just going to be a kick in the junk. But most of the day, well, awesome, Chewy. Hey, Eagle the Dragon, welcome on in. Glad to see you, my friend. 103 degrees yesterday. Are you in like Arizona? I'd expect that. Well, still a little early in the season to be expecting 100, triple digits even in Arizona, but getting closer. Mojave Desert. Okay. Okay. Well, like I said, hope everybody's doing well. I had a little bit late start in getting everything set up. I apologize for that. I've been adding a few things to the network. You won't be able to see them from here, but like I said, I work for Cisco, and I've got my new hybrid worker bundle upgrade when I finally got my new laptop. So I've got a Meraki MX75 security device, which has a 10 gigabit fiber port that you can add a module to, 2 WAN ports, and 12 network ports, the last 2 of which are power over Ethernet. Right. So, and you're saying, wow, they sent you that for your home? Yeah, that's the smallest Meraki device they sell. So, of course, that's got to be the smallest one that they can send. They sent that, as well as the MX40, I think it's MX44, which is the wireless access point. So it's about like that wide, that, that high, that wide, and probably about that thin, fully wall mountable, and it's power over Ethernet. So I was sitting down making up cables to pipe the stuff up here, and it's sitting over here in the corner now. But it was doing all kinds of weird, wonky stuff to my network last night as it was trying to get its initial setup and configure from the home servers back at Cisco. Yeah, I've been dealing with that, and then because of it, my streaming computer here apparently rebooted during that time frame, and the cameras weren't working right, and it was a mess. So, late day technical problems. Hey, Tech Jeeper, how's it going? Welcome on in. So we're going to be working on the Trident, but for now, I've got a plethora of stuff laying around. Hey, Kegel, welcome in. That I wanted to show you guys, and as I show you, I'm going to be like systematically moving it out of the way. so that I can actually get to the Trident, because I have some stuff sitting on top of the Trident right now. So we mentioned a couple of times before that one of the things that we're working on are a death racer and a drag racer for KB3D. They've commissioned us to build them their stuff for the show season. And of course, now I have a death racer. Diesel had one. We're making one for KB3D. Mrs. Dragon wanted one. So here's the start to Mrs. Dragon's death racer. We pretty much have the lower half put together. I've got everything I need for this. Let's say, except, yeah, because the box has the transmitter and stuff in it. So we have everything we need for this, except for a LiPo battery, which is the one thing that I didn't order when I ordered all the other parts to include a LiPo battery for the drag racer for KB3D. We went all black on the bottom to include the treads. So I've got one set of treads done. This is in Polymaker TPU 95. Hey, Pez Liz, how's it going? Hey, Petty Ruxpin, welcome in. So this one's ready to go on. The other one, I've got 3 more treads that need to be installed. So I need 1, 2, 3, 4, and 5. So I need 5 more pegs. The kit itself is short 4 pegs. They've made adjustments to the kit since I bought mine, so newer kits coming out would have a few of the right things. There's also been things where it's called for an M12 screw. Well, you have an M10 and an M14. There is no M12, so I don't know if they just tried to consolidate up or down to make the right number. There's a whole lot of the heat set inserts that are missing, so you have to work on that as well. But what we've got right now is we've got the drive wheels in place. The drive wheels are connected up to the motors and the gearboxes, and those wires are piped through to the inside here. The rest of it's all in the box. I haven't printed the top part. This will be the front of it with the fan that'll suck in air and push it over the battery and ESC. Time to break out the steel nails. No, actually, when we built the first Death Racer, we had a ton of extra 3mm, I think it's like, I don't know, 100, 150 long pieces. So Evil Diesel on Sunday when we went to lunch brought a handful for me. So I just need to, sorry folks, I just need to cut a few down so that I can go ahead and get the tracks installed. I did go ahead and print the seat, and then I think Evil Diesel has made a monolithic front and a monolithic rear instead of a bunch of multiple parts. So at this point, I'll wind up taking this apart. We'll print the front and rear pieces. We're going to do that on the bamboo and do it in different colors. And then the side panels, the side panels, we've got some neat ideas for that. So Mrs. Dragon, if you remember, her coin was a dragonfly. She's a dragon, but she's a dragonfly. So that's what we're going to theme this, is a dragonfly. So I'm going to hold off on showing any more unless she really wants me to show it off on stream. But that is where this is going. I can show this off too. So I need to sit down and make up some network cables, but this will be the back side with my switch and the patch panel. So we'll come out of the switch down to the patch panel, and from the patch panel we'll be able to come through these and bring in our Cat5 cables. But I've got 4, I'll say Pi/Pi alternative. So this one is a CM4 on a Big Tree Tech Pi sled. And then these 3 are Liber Elect Pi alternatives. Either there's 2 Altas and I think La Potato in here. I did change the mounting mechanism out. This is a lot more robust and a lot more rigid. The other one just felt really, really floppy. But this will be my little design. This is the power brick for the switch. And then I really wanted a UHP, but they were like $90. I don't know what the heck has gone on, but trying to get these in, everything I saw was import taxes and it went up like crazy. So this is an LRS 205, which means this is a 20 amp 5-volt power supply, which means this is what I'm going to be using to power up all of 40 amp. God, math on public. 40 amp power supply. I'm going to basically CAD in a standard switch wall plug like we use for our printers, mount it to the back, and be able to mount this on the bottom deck and power all of my Raspberry Pis off of this 5-volt. So that way I get a little bit of fun times playing with stuff. And that is the Mod 10-inch printable rack from Mandic Really. Okay. Spuds. Ooh, Spuds sounds good. Potatoes sounds good. Thanks, Mr. Wizix. I thought it was kind of nice. So if you guys like Cookie CAD, and I know you guys do, my mother had one of these and for whatever reason had taken it to church. She 5-finger discounts prints that I have laying around the house. This is a Flexi Factory kitten, right? It prints flat just like that, and it'll stand up and everything. My mom asked me for these in pink and purples, so I picked up Pink Elixir, Lavender Elixir, and I can't remember the other one that winds up being a mixture of pink and purple and kind of goes in and out. And she's going to give these to the girls at her church for graduation. And when I say girls, I mean like the littles, right? Because they like these things, they eat them up. So I am a Patreon reseller for Flexi Factory. I've never said anything about it. But yeah, so I'm making some of these up in Cookie CAD filament. I'm lucky in the fact that Evocate 3D, which is here in Raleigh, North Carolina, not too far away, especially not too far away from my office now. Yeah, they definitely shouldn't eat those. That is true. But they have Cookie CAD, they have Polymaker. In fact, I think they just got 6 or 7 pallets of Polymaker filament in. I think they've got the entire Panchroma line that was delivered. So they're also a bamboo reseller. So they're going to let us know when they can put in for the pre-orders for the H2D. They just don't have it set up in their system yet to do the pre-orders. So who knows? Maybe. I'm not too sold on it, really, because I have options here that do everything, and I'm not interested in the laser. And then we get into some projects. So this is a Kittytech X Pro. Not a +4 or 4 Plus or whatever the new latest and greatest is. This is old school. And when I mean old school, other than the fact that I don't know what it is with people that don't wipe down their printers, but I've been running into a lot of that lately. It's old school, and this is my DM, my dungeon master for D&D night. And you'll notice there's a bunch of parts in here. There look like there's some motors, something plasticky. By the way, that's a part cooling fan. And a box of parts. This box of parts here, whoops, are the extruders that he took completely apart trying to figure out what his problem is. Ooh, and you know what? I just realized something. Well, I'll be damned. We'll come back to this in 1 second. But here's the extruder setups. Here's the state of his hot end currently. Yeah, hot end's not going to work this way. So he brought it to me saying, "Hey, I could really use your help. I'm busy. I'm frustrated with this, and I'm just having a hard time. I need to figure this out." And so this is what I bring home. Of course, after D&D night, it's late at night, and I carry this thing like the full length of the block, right? It's not light. Surprisingly, it is an all metal construction here. And then I start digging into it, and this is what I find, and I'm like, you've got to be kidding me. So heaters, we can find those. The blocks, easy enough. These are thermocouples, not thermistors. They're thermocouples. Let me bring you all in here a little bit closer if I can. This camera, bring you in a little bit closer. Okay. So these are thermocouples. They screw into the block. And he's like, I'm getting thermal runaway errors. One of the tool heads just won't even work. Yeah. They're supposed to be attached to the printer. And this thermocouple only has one wire attached to it. The other one's busted off. Now, we'll go back here and let me show you something, right? Once again, this is the, why did you not? BTT X Pro, as in discontinued model, not making it anymore. When you call them about parts, they try and sell you a new printer. This tool head resembles a FlashForge creator from back in the day. I'm not sure if the thermocouples will actually fit though, but I have a set coming in from AliExpress. I also have a pair of Keytech ones used coming off of eBay that'll get here in a few days. So that's going to be fun. Hey, Mrs. You want to? That one comes here. And the other one will come. Thank you, ma'am. Duncan. Well, and that was something I was thinking of, Patty, is do I just replace them? So here's the problem. These two hot ends, come back up here. These two hot ends, interestingly enough, are PTFE lined. Not great. Even though this is an ABS printer, got the enclosure, right? It's marketed as an ABS printer. This is old school. It does have PTFE lined, right? You can get there. You can get there, Tech Cheaper. You just have to. It's a fiddle job, but you can get there. Getting there are, I want to say, a lot of research. There are some people that swap these out with micro Swiss components. The heat breaks are a different length. They're shorter. Means you don't get your bed close enough, so you have to go in and mess around and do things with the Z offset and stuff. So anyhow, my goal here is to make it print again. So I'm going to get the thermocouples in, and before I even bother trying to take these apart, I'm going to open up, get to the board, disconnect the old, connect the new to me old, and just see if I get good temp readings. If I get good temp readings, we got something to work with. And then we can try and take these out, because there's a lot of goop on the side of these too. So hopefully this breaks free without me sharing a bolt, because I really don't want to buy more components. I mean, I'm going to straight bill it back to them, but yeah, definitely some older school stuff. It is 24 volts, so that's good. But yeah, some older school stuff, and there's just, if you're bringing your printer to a computer guy and a 3D printer guy, please take a vacuum to it. I'm going to charge them for cleaning and maintenance, by the way. But anyhow, yeah, so this is one of the projects. I have parts coming in to work on this. And what I just realized was parts that I'm using for, or the parts that I'm having to deal with on another project, look exactly like these. And I just bought them for like 15 euro each. Which is a bit depressing, because if I figured out that they were the same darn things as the Keytech, I would have seen if I could have researched Keytech versus Optimus P1, which will be the next thing we'll talk about. But these extruders, you'll have a gear, just a straight spurred gear, a la, looks like Creality, right? Or you can get it that it's fully, the full teeth geared. Sticks through here. You'll have a spring over here, and basically it's just going to hold a little bit of slight tension on a standard bead bearing wheel, right? Here's the issue. This is all plastic, which means given enough time, you're going to wear a filament path through the side of this plastic. There's really not enough tension that I don't think it's going to break, but you are going to wear through that filament path. And I just ordered 2 of these, like I said, from, oh wow, where was it? Netherlands, or not Netherlands, no, Norway or Sweden, one of those 2 places. And now I just realized that the Keytech uses the same extruder system. So that's good. Now I'll see if I can find those somewhere else closer that might get here in under 5 years. These are big reverse Bowden tubes. This is a pretty decent printer. When it prints, having the dual heads, you need it to be a lot wider to be able to get full print capability out of it. Just look at the H2D and realize that you only get 350 if you're using both heads in a certain setup. So, hey, 3D Medic Vince, welcome in. Wilk Allen, welcome in. RFS 3D, welcome in. Nomad Max Stylings. Nope. Nope. First order of business, get rid of the 2 hot ends. Like I said, there are options, but he just wants it to print. The other thing I will tell you, tell you is if you're going to give your printer to somebody to work on, don't leave the two spools, like the two full spools of filament hanging on the back of the machine. That was like an extra 5 pounds just hanging on to the back of this thing. It's already back heavy. But, all right. So this one comes down, and we'll move it off to the side. And I can't bring the Optimus P1 here. I'm gonna have to try and figure something out. But the Optimus P1, let me pull up a web page. Of course, I didn't leave one up. Okay. Oh, yeah. This is kind of cool. Once again, here's the extruder off the Optimus P1 that I just had to buy because I didn't realize that it was basically the exact same extruder that the Keytech X Pro uses. So I wasn't searching for that. If we come out here to Optimus, you'll notice, oh, other than that, two different styles here. So you have the Optimus P1 on the left, which is open air, and you have the Pro on the right, which is fully enclosed. An individual has donated their Optimus 3DP P1 to Ecovate because it's just been sitting idle. This thing is bigger than a server cabinet. The print volume of this printer is 600 by 600 by 1100. It is a single tool head. Take a look at it here in a second. It's going to be an interesting little challenge, Tech Jeeper. And like I said, right now I'm just trying to get it printing again. Because I'm not sure what all's wrong with it. So I'm doing the same thing with the Optimus 3DP. I went down last night to Ecovate. They're not open normally Monday or Tuesday, but I went down with one of the other employees and sat down and started going through the wiring. Just tracing cables, trying to figure out what was where. They've got no manuals. They've got a few emails back and forth, but the individuals were having a problem with this as well, which is why it was just sitting there. Hey, Shrimp Father, welcome in. How's it going? How's it going, Zombie? So, Zombie, you're gonna like this. So, this Optimus 3DP, the P1 Pro. This is from FebTop or FebroTop. I can't remember exactly what it is. 600 by 600 by 1100, enclosed, chamber heater, right? Control box, it hangs on one side. This would be, I think, like a chamber heater or enclosed area for spools, depending on which options you get. Yes, it's like a server cabinet, and this does have dual doors. So the middle section here and the bottom door opens as one, and the top door opens. So if you're doing a smaller print, you can just open the top door and not worry about the bottom door, so you don't lose as much heat that fast. Because the chamber heater, okay, 600 by 600 by 1100 build volume means a lot larger size overall. The chamber heater is at the bottom. Fixed at the bottom. This is not a flying gantry. It is a fixed gantry, and the bed rides up and down, right? So the chamber heater is going to take a while to heat this if it's at the bottom, which is where it's at. Let me see. I think, can I click on it? No. What are we going to do? Optimus P1, P1 Pro. Click on this and see if it gives us some speckies. 600, 600. It says 1,000 there, but I have it listed as 1,100 for the Pro. Lots of little YouTube videos. Where are the specs? Cable drag chains, big cable drag chains, like CNC style cable drag chains. Here you go. The Z-axis. MGN 16 high wind rails on X, Y, and Z. You wanted to make a tall printer, but no idea what I would print. Yeah, we're going to have fun here. You could print a second kid. That's true, Petty. SFU 1610 Z-axis. These are ball screws. These are ball screws. So a 600 by 600 bed, an aluminum plate with a silicone heat pad, mains powered, with a glass print surface, aluminum rail framing, and 16 millimeter ball screws. The bed will drop down slowly to the bottom, right? What's driving it? NEMA 23 motors. And I'll show you some more on that. So the two side frames is kind of like a Ender 5 in a sense. So the Ender 5 Plus, your two Z-axis side frames come flat packed, fully assembled, right? You add the lower front and bottom, the gantry makes up the top, and then you'll have the bed itself. So it's interesting how it comes, but it's tall. It is really tall. It does have industrial grade wheels because you're not moving it otherwise. Yes, NEMA 23s. Fully enclosed housing. Here's your spec sheet. So NEMA 17 1.2 amp for the X and Y. Dual NEMA 23 2 amp 1.8 for the Z. And a NEMA 17 0.6 amp for the extruder. TMC 2208 quiet stepper. This is the weirdest thing. MKS Gen V 1.4 custom Marlin. And it is custom Marlin. We're going to have to try and get it because I'm going to have to try and figure out what all the specs are because I have a feeling we're going to swap that board out and clipperize this thing. An all 6061 aluminum body. 15 millimeter GT2 timing belts for X and Y. 15 millimeter belts for X and Y. Yeah, so here's where it says the build volume is 6060 by 110 centimeters. This thing is massive. Nozzle 0.4, 0.8, and 1.2. It had a 0.8 in it. Speaking of which, here let me just grab the hot end. It was fully built and in place on the machine. We took it off and we started noticing some stuff. So yeah, there you go. It has a 24 volt 60 watt heater with an NHC 100K thermistor. 5020 blower fan. No. Direct drive geared extruder. Yep. Okay. Fully auto bed leveling with an inductive sensor. So there could be something like a Super Penda on it. No. It's got a BL Touch. No, let me belay that. It's not a BL Touch. It's a 3D Touch. Right? So they bought the 3D Touch versus the actual BL Touch. But let me go ahead and show you some stuff here. Once again, this was fully assembled. It's now fully disassembled. And boy, howdy, let me tell you. I washed this. That is not filament dust. Clue number one. Okay. The connectors on this aviation grade pin connectors. Okay. They are keyed, so they only fit in one way, and then you screw them down. And whatever wires they didn't need, they just cut. This is from the factory. Whatever wires they weren't using, they just cut. So we have the extruder motor here. This 3-pin and 4-pin, this has a laser option. So that'll be interesting. The other side has the thermistor, the heater. We've got the fan. They said 50-20. I'm pretty sure that's a 40-20, not a 50-20. How do I know that's a 40-20? Well, that's a 40, and it's not bigger than that. So this is a 40-20. The 40-10 is Bluetooth. This is the wireless fan. It works really well. No, this thing is seized. Yeah, this thing is seized up. It not completely, but it's not moving freely. So we're going to be replacing that because Bluetooth wireless fans don't work. We're getting a new one of this since I was digging filament out of it. It spins, but we'll put a new one in there. There's the BL Touch on a warped mount, which happens to be PETG. You know, hanging off the front, or excuse me, the rear of the print head. So I've got to find this part and reprint it. See if I can't get any stuff from them. Stepper motor. It's standard EMA 17, branded with their company. Right? Hey, Big Jano, welcome on in. Thank you for the 13 months subscribe in a row. Once again, this fan. So interesting fact, right? Extruder up here, hot end right here. This fan was mounted like this. This fan was mounted to the front of it. Now, I wonder why this is seized. This fan, with plastic all the way around it, with through screws bolting these two fans together, does anybody see an issue here? Anybody see an issue? Like, I don't know, maybe this fan has no way of actually getting in air, so it's creating a vacuum? Yeah. You've basically hooked the back side of a fan to the front side of another, so there's no way for this to get air. They burn this up because there's no way for this to get air. Exactly. Well, like I said, this is a straight flat back. So as soon as you put that together, there's maybe a little spot right there where you can pull some air. Otherwise, there's no way because that's a solid back. So no wonder this fan burned itself out. And I'm just going to say, what does that look like to you all? Yeah, they had to be spacers at one time, and they're going to be spacers again. So once again, the heat sink goes right here. Extruder pushing filament down, which means the nozzle's coming out here. Zombie, Tech Jeeper, what does that look like? Bearded Printer, what does that look like? Deanna, what does that one look like? I know all of you guys should know what that looks like. Because that's not rust. Arc flash, or they started a fire. Because all of this is not rubbing off, it's not wiping off. That to me screams, yeah, looks hot. I bet you they set this hot end on fire. Because when I took everything apart, this is where I said once again, hey, this looks familiar, doesn't it? This looks just like the Kitty Tech. This has that discoloration damage on it, but does that look familiar? And you can see it was about to bust out the side there, and it already had, and there is visible light through that crack. So the filament, this is plastic being pulled through plastic. Yeah, so it's a worn end feed. So I was going to have to order this. I couldn't find parts for the Optimus P1 extruder anywhere, so I ordered it from the company, which is in Stockholm, Sweden. Paid euro conversion for it earlier today. And then I just realized it's the same exact extruder that the Kitty Tech is using on the X Pro. I'm like, darn it. Hey, Heathen, you're here. What does that look like to you? Knowing that extruder motor's sitting here, hot end's right here, which means that's the business end of the hot end with the nozzle and the heater block and heater and all that good stuff. So anyhow, there's the heater that was in it. Bare, no goop, 50-watt heater, right? It actually comes with a 40-watt from the factory, so this has been replaced. There's the thermistor wire, right? I took the set screw completely out, and I'm going to have to punch this out, like literally use a punch to punch this out. But have you ever seen a thermistor that's been, like the ferrule's been crimped on it? So I don't know. I've got new parts coming. Like I actually have some standard thermistors coming and a PT1000 thermistor coming, because I've got several 65-watt. I think I may have another 100-watt sitting around somewhere. Because once again, this printer is 600 by 600 by 1100. And they had a 0.6 nozzle. So here's the heat break that I took out of it. That's the cold side. There's the hot side. That is cooked PTFE. Hey, Sprinkle Bat, how's it going? Welcome on in. Welcome on in. Who just rated me? Sprinkle Bat, you rated me. Oh, hey, welcome on in. Welcome on in. Yeah, could have had thermal runaway. Yeah. So yeah, this I have new parts. It's just better and safer. The bats are swoop. Swooping down to eat your snacks. No eating my snacks. Hey, welcome on in, Sprinklebat. Hope you're doing well tonight. Welcome in, Raiders. Everybody that came in with Sprinklebat. We're doing some chatting right now. This is a project that I am having the opportunity to get involved with. As you know, I like to build 3D printers. I've built a lot of 3D printers. Yeah, Layers with Bully. How's it going? Welcome in. Welcome in. And so Free Heathen. Oh, you're gonna be right back. So this, whoops, if I put over here, this is the printer I'm having the opportunity to work on. This is the tool head out of this printer, which, by the way, does have a laser module that you can use in it as well. Thankfully, it didn't come with said laser module. But to give you an idea, how big this printer is. Yeah, it's a big one. It is a big one. They brought it out in somebody's truck and they had to take some of the panels off and disrobe it and crank it into the building at an angle. A laser module, how unique. Yeah, it's funny how people are putting laser modules on their enclosed 3D printers. Need a laser or a 3D printer? Lasers give off smoke and other debris that is not necessarily good for the mechanics of a 3D printer and vice versa. Yes, so this is 600 by 600 by 1100 build volume. So we've got a titanium one of these coming in. Hey, look, I happen to have a gift here from Fadus at one point that happens to be a 0.6 hardened steel nozzle to replace the brass 0.8. So here, once again, let me get back over here where it's nice and big. Yeah, I don't know what they were printing, but the filament that was in it was white. And there should be no PTFE going down into this. So I don't know what they were printing with, but it cooked well. And I'm not even sure if I'm going to try and clean this out. That thing's almost as big as your ego. Oof, duh. So here's the heat sink. It's a heat sink. PTFE tube goes down about midway. And then, of course, you have the PTFE lined heat throat that then would go in there. Once again, with no thermal paste to add any thermal conductivity. And it's held in with a set screw, and then it's mounted to the plate from the back into the heat sink. So, yeah. So I've got replacement parts coming in for the majority of this. I mentioned high temp, so I figured I may mangle this up trying to get this out and just feeling this. This is an aluminum block. So I figured, what the hell? And I've ordered a nickel-plated copper block that's good to 400, I think 425. You know, the PT1000 thermistor. And as long as I can get it to work, we'll be able to run hot engineering materials and do big things as well. And besides, I have a feeling, Zombie, that I'm going to have to test this printer out using, I don't know, a VChonk file. So yeah, so this is the cluster that happens to be the hot end, right? So we can only go up from there, don't you think? I mean, other than the fact that it was filthy and we needed to clean it. Yes, copycat. I wanted one, but alas, that's only 300. That's only 300. And the Ender 5/0G downstairs, the Ender 5 Plus turn 0G is 370. So I need 400. And besides, you were doing like full plate to get yours, and I'm going to have room to spare. So this is the electronics box. Okay. Dual 110 power cords. This connector goes down to the heater. My notebook where I was taking notes as we were trying to trace what wires do what. Various screws that we pulled out of it. And I'm going to have to do the overhead camera for this. Work, please. Okay. So, this is pretty much literally how we found it. The fan was mounted here, so I did take that off. But I don't know. I think this is going to work well. So the plugs were in this, but mind you, this one's well secured as well. So these are for the Z stepper motors, and they're daisy chained together. Notice that a couple of the wires have come out. Every single screw down terminal in here is bare wire. These terminal blocks, of which there are a couple that have come out from the terminal blocks and are just free floating, are distributing 110 voltage. So yeah, distributor blocks distributing 110 voltage, free floating, you know, real safe. The SSR, so the one SSR here, which I think we traced it out. This is for the chamber heater. I looked at it and I was like, wow, that's wiggly. And in the process, the bare wire came loose, and this is the ground side. So now we have the ground circuit for 110 kind of floating around. But yes, we have I think this is a 2208 for the X motor in dumb mode, not UART, in dumb mode. We have a 2209 for the Y, once again in dumb mode. We have a step stick, it's the step stick breakout board, and that comes over to one, and then they daisy chain the two CNC style drivers, because once again, these are driving NEMA 23s, 2 amp NEMA 23 motors running 16 millimeter ball screws on 16 millimeter linear rails to raise that 600 by 600 bed. Yeah, the dip switches on here set the current and the micro stepping. This one had micro stepping set that matched, but there was no current set on this. So this would have been running at 2.8 amps, where the other one was running at 4.8 amps. I don't know, if you send different power to two motors that are supposed to lift things in sync, that might be bad. What would be even worse is if the micro stepping was different between them as well. And then we have the extruder motor. We've got another step stick that's got wires to it. but there's no step stick in it. The only thing that we can think of is it goes to the same place as the extruder. So that may be the other empty 4-wire that would most likely be for the laser module. This power supply is a Meanwell. It is an 1800 watt, is an 800 watt 24 volt power supply. It's free floating as well. There's no screw in it. So yeah, this is going to be my wiring project. We will wire this on stream. Hey, Jano, this kind of looks and feels familiar, doesn't it? Yeah, if you only had warehouse size space. Exactly. So yeah, I'm going to, like, the only crimps on this darn printer or connections on this printer that are good are the JST connectors. Every single one of these power wires is unferruled, so it's bare wire, and I can see bare wire in a couple of places. This is the chamber heater, and I've got bare wire jammed into the back of that. There, I think that's the ground lug connection. This is the SSR trigger. This is to the thermistor. So yeah, it's a slight mess that I'm going to clean up, rewire it, and I was sitting there going, okay, I'm going to have to bring all my tools down to the shop to work on this. And we got to thinking, it's like all the wires on the printer screw on, like push in, screw on. Why don't we just undo them? They're labeled A, B, C, D, E, and H. Unscrew them and just take the whole cabinet. Because once again, the cabinet's supposed to be held on with 4 bolts, I think. It only had 2 in it. It was quality. So yeah, this is going to be a fun little project to try and rewire and really understand where all of these wires are going down here and see if we can't clean some of it up or at least make it less likely to shock and kill somebody in the store. And if I can make it run, then, you know, I'm going to run prints on it. You know, I think I earned that. And then, like I said, at some point we did have a thought of, do we swap this out with something else? Because this is an MKS Gen V1.4. It is an older board. We can put something like an octopus in there or what have you. Or just about anything. The screen, of course, is in a 3D printed housing, which I believe is PLA. This might be PETG or it might be PLA. This fan riser angler thing, because that is definitely not factory. That was printed by this whoever had it. I don't think this screen is Clipper compatible. I think it's, you know, the MKS screens that plug directly into the board, I do not believe those are Clipper compatible. So we may have to do something with that. But yeah, this is going to be a fun little project to work on. And that's kind of the projects going on. Once again, a couple of death racers, a drag racer that all the parts just came in for. This, we'll say a cluster. That's how I referred to it last night. And when I first came home and was trying to show Mrs. Dragon, who actually had her mom on the phone, and her mom was like, ooh, I want to see what a cluster looks like. So I showed her. She didn't know really what I was talking about, but she did get the gist of, you know, mains power. Like everybody's stuck their hand in a light socket before or an outlet. And by the way, this does have an emergency stop, which is good, considering it's running mains voltage for a 600 bed and mains for a chamber heater, and then an 800 watt to run everything, or yeah, an 800 watt 24 volt power supply to run everything else. It's it definitely could use the old emergency stop, but we are definitely going to work on making that safe. And I'm like, God, I've got 3 different coffee cups here. I don't know which one to drink out of. That one and that one we'll keep over there and closed so they can stay warm. So we left off on the Trident build. Once again, the Voron Trident. This is my 350 Trident that we are converting over to the Siboor CNC metal parts, all-wheel drive. So we'll have 4 motors running the Core XY gantry system. It went from 6mm belts to 9mm belts. And where we left off was starting to install the TakeOff tool head. And for those of you that weren't here on the last stream, and I'm going to apologize for the way this looks. This is people designing CAD with a weird orientation. But this is basically the TakeOff tool head. So this is your carriage in the back. So the fans are in front of and behind the hot end. The Calamity tool head basically turn 90 degrees and the fans will be to the right and left on the x-axis of the tool head. So the way this is going to work is we'll mount our extruder up at the top. We'll have a tube that comes down and goes into our Chube hot end. We do have our Chube hot end that we started preparing. We've got our power supply here, our heater element here. This is a 100 watt 24 volt heating element. Once again, we've got a big melt zone here. We've got a, what is this? A 1.0 nozzle. So 1.0 hardened nozzle in here. This is an Undertaker nozzle from West 3D. And a PT1000 thermistor. I'm going to route these wires up because it's going to come out the same side as the heater wires. And we took this apart, and I was using some, I was misnaming some things yesterday. I kept saying that this was the chalice. That is not the case. This is just the shroud. These are the heat sink fans for the air version. Chalice is the top machined piece that allows the filament to come in a nice path. So the nice thing is looking at this, this mounts with 6 screws and they're M3 by 12 screws. So we're going to have a really good connection. The fans here are 36, 28, 12 volt fans. So we're going to have to extend the wires on these, and they're going to have to go all the way back to the motherboard, because if we put a tool board on this, which is what my plan is, that tool board only provides input power to the fans. So if you're running it on 12 volt, then it's going to get 12 volt. If you're running it on 24 volt, it's going to get 24 volt. On things like the SB2209 board, you do have jumpers that you can change the voltage. But on the EBB 42 and 36 boards, you do not get that. And my original thought and plan was going to be to run the EBB 42 and run it in CAN bus, because this printer had a SB2209 on it, so it was already configured for CAN bus. So I was going to stay CAN bus. I've got a, this is designed to support beacon over here on the other side. But what I've got is a cartographer, which is an alternative form of a beacon. And the cartographer can go USB or CAN bus, and it's already flashed for CAN bus, so I should be good to go there. Now, with that said, the one thing I'm going to look at is I think Chube is another board in the same form factor, and I might want to check and see if they support different fan voltages. If so, then we'll swap and go that route. Okay, so let's change to this view, and I'll get my thing out of the way so I can bring the beast up. Once again, this is a 350 Trident, so when I say beast, I do mean beast, and I think we're still in zoomed in view. Somewhat. Angle. Okay, well, where we're at. So, previously I had run a USB extension cable through here, and there's a huge reason. If you have to reflash a CAN bus board and you're having issues with it, you flash it with USB-C or USB. So having an available USB that you can plug into without having to flip it on its side, and it makes it easier for flashing boards. This is our original CAN bus cable. We have a couple of cables for the previous motors that we need to take out, and a mystery wire here that I have no idea what it was connected to. So that will come out because we're going to work on wiring up our motors. All four of our motors have a pigtail, so we should have cables to wire our motors up with. All right, good night, Lily. Have a great night. So what I'm going to do is kind of just lay these out and look at them. I'm assuming, or at least I'm hoping, that one, they're long enough, and two, they that they're long enough, and that there's longer, like there's two longer ones and two shorter ones, because you would think that the longer ones would get routed and then come down the back as well, because there's no real easy way to run those wires unless you do that. Okay, so that one's not too bad, but I have a feeling that these might all be the same size. Which case we might be making some cables. Yeah, those two are the same exact size. And no way that that is even coming close. These look like they may actually be shorter. So how's everybody doing today on this fine Tuesday evening? Got to go over a few of the projects that we've got going on here and chat a little bit. Now we're getting into the printer work some. Yep, so far they're all the same exact size, which means the only way the front two would work is if I take them down the front pillars. And no idea how that would work. I think that this is going on like a micron or something. Yeah, I've got 4 wires. They're all the same size, and neither one or 2 of them might be long enough to move the pigtails from the back side down. So once again, on this printer, the whole gantry is fixed in place. It's not a flying gantry. The bed goes up and down. On the last stream, we've got our gantry rebuilt. We took one piece off at a time and swapped it out. So our gantry should still be square, straight, the whole 9 yards. You got a manicure that this morning. That's awesome. We got our belts run, which was a little fun because of the way that they go, because it's an all-wheel drive. So basically, opposing corner motors are working together. Yeah, opposing corner motors work together, and they're all going to be individually connected. There's going to be a way that we did it on the VZ bot, and we'll do the same thing. And I believe what it is we're going to loosen some of the motors or the pulleys on the motors, energize them, do a couple of things, and that's going to basically sync the motors so that they're not out of sync and out of step. You had your haircut with little highlights. Yep, Petty and Manny too. Exactly, Eagle. You had a fun day. That was your birthday day, right? So I'm trying to think through this on how we could do this. There's no real way to route the cables effectively and efficiently. My thought was to bring these cables up, run them along the top edge, drop them down with the other ones, and kind of somehow bring them across, drop them down with the other ones down the inside edge here. And there's no way that these cables are going to be long enough to do that. I'm literally, it might get me to the deck panel. And no, it's not even going to do that because I'm going to have to jog over to the side. So there's no way that these are going to work. They may work on a 250. They're not working on a 350. The only way I can conceivably think of it working on these fronts is if we bring the motors or the wires down and under, but that would require different mounts because there's no cutouts internal to these mounts to let the wires go through freely. Okay, for starters, I believe what I'm going to do is I'm going to go ahead and take these rear corner pieces off so I can get to the wires. And that will let me eventually take the wires that need to come out, and we'll get those moved out of the way. And we will come back in and at least wire up the back motors and get those going. And the front motors, like I said, I may wind up having to either get longer motors or I'm going to have to extend them one way or the other. Not longer motors, longer wires for the motors in order to do this. So what I did was just undid the 2 screws. They're on there with hammerhead nuts. So you just undo the 2 screws, pop that corner off. We'll do the same thing over on the other side. And once again, that's going to let me get to the wires and pull the motor wire and that extra wire out. And it'll also let me route things a little bit easier when we go to route the new wiring. Then I think what I'm going to do is push this forward. Darn it. Forward. I'm going to lean it towards the front. No, I can't do that. If I lean it towards the front, there is a thing on the front there, a display that I will bust off. So we don't want to do that either. Okay, sideways then? Yeah, we'll lay this on its side. We'll watch all of our cables go sliding. Okay. And let me see if I can't turn this around slowly to show you guys the business end of the equation here. So here was our electronics setup. Sure, what it is I am scraping there. There's definitely something underneath there. Okay. There we go. I'm going to stop moving it because I feel like I'm scratching something up. What I need to do is pull these wires out. So I'm going to start trying to pull or push the 4 motor wires out here. See if I can get the motor wires and not the light wires. There's the motor wires. And then this is that other wire that I have zero idea what it was going to. We'll find it when we trace it all the way down. And we got our trough, so we'll have to pop this stuff off the trough. Where'd you go? Still going. Down here in the middle. That was in stop wire. Oh, yeah, it does. The 5-volt source. I have a feeling I had just a light in there, and then I switched over to the RGB lights, and they're routed to a different location. That makes some sense. Darn. Speaking of the ergoba lights, there we go. There's a wire that we can recover and use for something else. Thanks for the lurk there, Big Jano. Big Jano's been doing his own computer rewire project. And I know that's been loads of fun. Okay, so we've got our motor wire here. Need to see how best to get that pulled out. All the other wires that are in there. Yeah, sometimes doing the wiring stuff, you kind of make it harder for yourself if you ever have to get in there and redo things. There we go. That one's out. Come down here and go through there, all the way at the bottom of everything else. So see about pulling a couple things out so that we can get this out. Pop it, pull it, move it one way or the other. These back in there so that they're at least routing again. I wrapped up in around something. Big cable wire in there. The motor. Take the A motor out because do the other side. Can I help any? Probably not. Did. There's the B wire. So I have a B wire and an A wire. B is the left rear. A is the right rear. And then crap. Who notices the issue that I'm going to run into? So just like the LDO 2.4 that we wound up rewiring for the Leviathan board, this is an M5P. Works great with a Trident with a CAN bus toolhead board because you have an A, a B, and 3 Zs. So you need 5 drivers on the main board. We've now got 7 drivers needed, 3 Z motors and 4 gantry motors. Which means we're going to have to do a brain swap on this. Great. Yeah, we're going to have to do a brain swap on this because we're going to wind up switching over or having to switch over to a Big Tree Tech Octopus or something along the lines of that in order to have enough outlets for our motors. Okay. So that's a fun revelation. That is a fun revelation. Cable, lights. And of course, I actually have a zip tie around this one. Just a zip tie. Apparently not yet. B motor. Excuse me, not B motor, the A motor. So we're gonna have fun. We're gonna have to rewire the whole printer to make it work for us. Great. We can do that. I've got a octopus board over there. We'll just have to completely reflash everything in the process. So what do we have here? We had the end stop, the CAN bus, and the lights. And I have a feeling the CAN bus we're going to have to route differently. Okay. Not the fun I was hoping for tonight. I guess one thing that we can do right now is we're going to need to swap, or not swap, but add in some spacers for the 3 Z motors. So we should be able to do that now. What we're going to have to do is pull the, we'll pull the 4 screws holding the motor out. We'll pull it down some. We'll add in our spacers, put it up, put 4 different screws that are a little bit longer length in. And I'm going to procrastinate while I think about having to do this, because the other thing I'm going to look at is this is a UHP 200. I'm not sure if this is going to have enough amperage to run 7 motors, the hot end, and everything. So we might have to upgrade this to like a 300. Yeah, this will probably have to go up to a 300 at a minimum, because we're adding 3 more motors in. Anyone update Bamboo Studio yet? I have not. I don't intend to, because I don't have one of their new printers, and I'm not sure if I will have one of their new printers. We're going to need this. What I need to do, I need to double check and see what length screws we need for these spacers. M3 by 25 socket heads. So come down and find my M3 25 socket head screws. Let's get these ready. And once again, what I'm going to do is I'm just going to take out the 4 screws holding like this motor, and we'll add in a spacer which will just make the motor a little bit lower, and at the same time drop the lead screws down. I think it's 13 millimeters, which gives us more space for our takeoff tool head to move around. That's what this mod's going to do right now, is just give us more space for the tool head itself to move around and not get hung up. So when I was ordering parts today, I was chatting with KB3D. He told me to go configure the Frax kit so that once I get my Frax kit parts in, we're going to set up and do a joint stream as we build our Frax. And of course, he said that, and I didn't think twice about it and hit the purchase button. He was like, "You weren't supposed to do that." Oops. Force of habit. So I'm holding this now as I'm pulling the last screw out. So this is the piece that we're going to add in. It's a two-piece design, which makes it easier when you're retrofitting. You can pull this down, slip that part in, the U-shaped part in, kind of spin it around. Take the other part, slip it in the gap, push your motor back up. Now we're going to use our M3 by 25 screws. And we'll start running one of those in. Line up, there we go. Get one lined up and start biting in the motor, then I can go ahead and do the others. There's one. You can get two of them going, preferably on opposite corners. Then the other two become a lot easier to get aligned. Just like that, we've got some spacers that drop this down, like I said, 13 millimeters, which will give us a little bit extra room on our tool head, because the lead screw motors themselves will be lower, but they're not going to be low enough that we won't have enough travel to drive the or to get our first layer printed. Okay, so that one's there. We've got our spacer in. Once again, this is the distance that we're adding. This is basically filling in the inside well to make it easier to get in there and clean. I think I'm going to move around here, possibly to do the next one. No, that's not going to work either. Screw. I have been watching, I was trying not to, but I did start watching some of the videos on the new Bamboo. I mean, the hype is out there. Everybody got theirs. Everybody's dropping their videos. It's all cool. It's all good. I don't know I don't know if it's going to be for me. Right. So the rear Z motor had kind of like a printed part that was around it that held it in place. These don't. So just be very, very careful. You don't want to bend your lead screws in the process of trying to add these spacers. Again, we're going to get the spacer in, turn it around so that the opening's facing me, which makes it easier to get the other piece in. Should make it easier to get the other piece. Should make it easier. Should apparently being the operative word there. Oh. And once again, we'll try and get one of the screws going in, and Edutech got one too. I watched. I started watching one. I think it was Samcraft, and he was doing a live stream, and it was already out and set up by the time I was able to join. I was like, okay, well, that's not helpful so much. And then I watched 3D Printing Nerds, and that worked out pretty well. I mean, a lot of features, a lot of different packages, a lot of upgrades you can add into or grow into type of thing. But like I said, I'm not 100% sold. Which way are you wanting to go? There we go. Not 100% sold on like the need for a laser, and you do lose some print volume in single head mode unless you do the trick where basically you load up the same colors in your AMSs that are attached to two different nozzles. Which is what I was thinking was going to have to happen. Yeah, he had a lot of info in his unboxing and review. I didn't watch CNC Kitchens fully yet, so I will watch his. All right, so 2 down and 1 more to go. Really wish. Wonder if it's just the head of a bolt that's sitting out from the panel mount that's making that noise. Last one's going to be fun just because of the way it is. And I had not even thought about this having hadn't even thought about this having a smaller MCU in it. Okay. Push that in. Pull the last screw out. Kind of hold it in place. Grab your printed part, because why would you have had that close at hand? Place you. There we go. All righty. 3 for 3. Now, let me see. I probably have to get these from the other side. So because we're going through a bunch of plastic, we're of course not putting any Loctite on these screws. It will make your plastic brittle. Don't do it. Don't test your luck. Right. So our 3 motors have been dropped 13 millimeters. So that gives us some more room on our gantry to move our tool head around. I honestly don't know if I wanted to get into this tonight and start tearing this apart. I mean, we're going to have to one way or the other. This wasn't something I was looking forward to do today. Okay, because when we do this, that's using a CB1, so we're going to have to completely redo it. We're going to have to add a Raspberry Pi. Well, not necessarily. I just don't have a Manta M8P on hand, I don't think. Because a Manta M8P would work. We could keep the same CB1, which at least keeps our brain stuff functioning. Let me take this off and get this out of here for now. If we go with a Manta M8P, we get the CB1, we get our 8 ports. We'll also get still going to need to deal with those wires. That screen will still work because this is a screen that works with the CB1s. So, I think what I'm going to do, put these back on for now. We're going to order an M8P. And get that fast tracked. We're also going to have to get a new power supply because this power supply is not going to foot the bill anymore. It's going to be I don't know. Too big for that one. Yeah, if we're using it an M8B, that gives us the ability, hopefully, to just kind of swap some things between point A, point B, and should make the transition a little bit easier. We're still going to have to do some reconfigurations, but we can still maintain the CB1. We'll have to get a new power supply, and we'll have to get the new MCU. Oh, that I was like, what was that noise? Yep. Dang it. You guys watched me do it and didn't tell me no. Oh, okay. So we now have screws everywhere. That's okay. We can get them back in here. One more. Okay. So I think what we'll do now, since we were stuck and we're going to need to do a brain swap, is let's keep working on the toolhead because we can. So move that forward so you guys can see a little bit better. And what we're going to do is start laying in our tube. So you kind of have to build this up in the appropriate way. Otherwise, you kind of dig yourself into a corner. So we've got our tube. And I say that as I go, yep. Hopefully, yep. Okay. So our tube is going to come in this way. Our wires are going to have to come up and over the side. So we get tube lined up, kind of push it up in there. And there is going to be some PTFE tube that goes down through here. And these are M3 by 12 screws, which luckily I have them here. They're not black, but I think you guys will forgive me about that, right? Or do I need to go get the black screws? Do I get black screws? Let's go get black screws. Everything else here, that's kind of a mixture of black screws and other screws, but let's stay with black. We'll go with black. M3 by 12s. There we go. Another case full of screws that we can dump somewhere. Okay. Once again, tube's sitting in here. We're going to get that lined up. And there's 6 holes, so we're just going to start getting one in the front, one in the back. Now these are, I'll say, words on stream. So these are straight through holes where the other ones have a bit of a slot on them so that you can also mount things like a dragonfly or something else using this mount. Or not a dragonfly, but a dragon or a um, Rapido, something like that. As long as I got these lined up and they're going to go in. I do want to put some Loctite on these. There's 6 of them, but I don't want any of them coming loose. A little bit of Loctite on the threads. Pop this one back out, put some Loctite on it. Now, you've been using Orca. Been holding back. Yeah, I have not updated. In fact, I have not updated the firmware on either one of my X1Cs since I bought them. I see no need to update them. And especially not now with all the shenanigans. I mean, I'm still using Bamboo Studio. But at this point, I haven't updated it either because my biggest fear is they're going to update Studio and force you to update the printer. Now, granted, if I do wind up getting an H2D, I'm most likely going to be forced to update Studio in order for it to, well, I will. I'll have to update Studio for the software to work with that printer. But once again, I'm using it only for the Bamboo printers. It's really, it's not going to nerf me in my use case the way I'm using it. So, sorry about that. It won't nerf me. I use Bamboo Studio for my bamboos. I use Orca for just about everything else. I use Prusa Slicer for my Prusas. I was starting to use Prusa Slicer for the rat rig, and I still can. If it's up, I'll use that. But the rat rig with the IDEX functionality, their quote unquote full feature profile is in whatchamacallit, Prusa Slicer. Coming soon to Orca and well, actually it's in Orca now because they released the latest version of Orca, which did have the printer profile for the thingamajob. Okay, so now that we have our tool head in, we can work on the fans or we can work on the top. I want to go ahead and get the fans connected. And when we do the fans, I want the wires coming out on this side. And you need to be cognizant of which way the air is flowing. In this case, the air is flowing down, so your connectors are going to be on the bottom side and the sticker side facing down, because that's the way that you're going to have your stuff blowing. Okay, so these were down. This two are up. Dang it. And I did these two on the inside so the screw heads come down. So the only way I could do that is if I take the tube off, undo the mount the at least two sides of the fan, because I'm a dork like that. Maybe. How did I do this? Ooh, no, maybe I did it right. Maybe I did it right. Okay. So I believe the mounting fans, or the fan mounts, or whatever, Let me look at the CAD. Bring that up real fast. So our fan screws are M5 by 35s. It shows button heads. There's nothing going to be in the way, so you can use button heads or you can use socket heads. I'm going to use socket heads because that way everything so far on here is a 3mm socket head, and I want to be able to grab one tool and take everything apart here and not have to keep grabbing different tools. Hey, Evil Diesel, about time you came in here. You missed the whole show and tell. I mean, you've seen pictures already, but we were going through and looking at the wiring of, or actually the toolhead fiasco on the PDX Pro and the wiring fiasco that is the Optimus P1. But I've already shown you, I sent you the photos. Interesting thing to note on that as well. What I found out was I just ordered the plastic extruder parts for the Optimus because the extruder was getting worn through. It was almost ready to crack from filament running through it. And lo and behold, as I was sitting there looking at the kitty, they used the same plastic extruder parts. So while I just ordered plastic extruders from Webtop, which is a Swedish company, it looks like I could have just as easily have looked for Kitty Tech and maybe found the ones somewhere local. So I'll see if I can find some local. So what I need to look at is my Cartographer, because once again, it can be mounted via USB or CAN bus. And I believe this is a CAN, well, it can go either way. Really, in the USB, it's 5-volt ground, and then it's data minus, data plus. Or if you plug it in CAN bus, it goes CAN high, CAN low. Hey, Waters, how's it going? But what I wanted to look at here was on my Cartographer, because once again, I'm going to use the Cartographer here. One is to make sure it wasn't all flat. This is a 90-degree version. I also wanted to look at the mounting holes and make sure that they line up and we weren't going to have an issue like, well, that goes barely. Yeah. So that'll go there, and it's going to be easier. No, it won't. Dang it, it doesn't fit. So there's the Cartographer, the way the boards step, right? The way the board steps on the sister here, because it's a 2-part board design still. If I go to try and line that up, the screw holes aren't going to line up. I would basically have to put it in an angle, which should not be right. It's not going to line up. And because of that, I'm not going to be able to use the Cartographer on this. I'm going to have to, I think I've got another Beacon H sitting over here that was destined to go on, oh, man. So the Beacon was destined to go on the, whatchamacallit, the VZBot. If this is the right one, and this is not a right angle one. All right, so we'll mount the fans, and I will deal with the pain of manually dropping the bed, so that I'm probably gonna have to manually drop the bed anyhow, but that Cartographer won't work. Hey, Waters, you guys don't have beacon probes, do you? So Waters is my my hookup over at Evocate. He's the one, or Echovate. He's the one that was chatting me up at 3D Printopia, and what am I looking for? We said M3 by 35 screws, right? I think these are the M3 by 35s that they provided. They only provided 6. Why would you provide 6 of? Murph is not coming fast enough. Yeah, I feel you, Evil Diesel. All right, so we need M3 by 35. Oh, well, we need M3 by 35. Let me move this over the way so it can be a tripping hazard. See if I got the M3 by 35s over here, because I don't believe I have them on the main rack. Too long. 40s. Well, maybe I do have them over there. We shall see. 30s. 30s work? Probably not, because those are 28s. 30s don't work. I guess we'll use their 35s and we'll be too short. And, oh, no, we'll be good. We'll be good. Drop something. I think I dropped. I don't know. And I'm talking to myself. I really don't want to switch and do some button heads, so we'll mix and match, and we'll put the 2 black ones in the back somewhere so that they're not as visible. Okay. We're going to have one of our fans. We're going to come down from the top through the fan, and we'll screw into our lower fan mount there. We're coming from the top on these front 2 edges here. What's going on? I know I've okay, so these are, and let me double check these. I'm assuming these were 35s. These might be 40s. Let's double check. They're 40s. That would be why. These are too long. So with that being said, now we're going to check and see if the see if I've got button heads, and we'll do button heads instead of oh, we got plenty of M35 button heads. Well, so much for that idea of trying to keep it with only one driver side. First time west of the Mississippi. Nice, Waters. Pretty sure you're flying to take stuff home for Bev. I believe she's going straight from her Murph to another event. I also told Bev that if she needed to, I should have some room somewhere, somehow in the truck, or either in the truck or the Subaru, because we'll have both cars. We're driving both vehicles. We always take the truck because the truck allows us to carry a bunch of the printer stuff with us. And the Subaru winds up being primarily luggage. Okay, so one there. Bring one in from the bottom. Other one from the bottom front corner. Yeah, it should be nice. We shouldn't have any vehicle surprises this time around, like last time where we had an engine blow up on us. That was loads of fun. I would suggest not doing that. Loads of fun, but not fun. All right, so this is the fun part, is now we're going to have to drop this bed down some more. And don't worry, we'll have fun. We have Z-tilt adjust. I may have to good gracious. Two back ones in. Now half of Velta and the other half of Frax Press. Yep, I talked with KB3D today. And ordered my Frax parts. So once that comes in, we're going to do a joint Frax build. What is going on? I make a comment, but the peanut gallery's here. Just don't break it. Why? I've got enough broken projects I'm trying to fix. That one there, this one here. Let's see if I did the wonderful thing, which was actually did these the right direction. Okay. Talking about another mug. Yeah, I still need to replace that mug. Come on. Okay. So we've got the fans on. We've got the tube in place. We've got this whole SLM printed metal whatchamacallit, mount, which is acting as a heat sink for tube as well. So that's good. Making sure that everything's nice and tight. And I don't want our fans falling off. There we go. So we've got our two fans. We'll be able to bring those around, send them up however we need to. Like I said, I want to use the Cartographer. The Cartographer is not going to work in its current form. So I may either need to get a different Cartographer or get a Beacon H, which this is designed for Beacon. And it's the two-part design that's messing up the fitment right now. So if this was a standard, like one-part design, it would probably fit. What's the Cartographer? The Cartographer is a eddy current probe similar to our Beacon. The difference is it can go USB or CAN bus, which means it can also be plugged in. Well, in this case, it's apparently a little bit tolerant, so it can be plugged in through a toolhead board. But there's the Cartographer, right? So there's the business end, and you've got, if I can hold it to the light right and get it to focus. You'll see the round circular pattern there. That's the magnetic coil that's being used to sense the bed. Now this does support. Oh, I'm going to get it mixed up. So give me 1 second. Survey touch. So as it says here, come on, focus. Focus. There we go. It is pre-flash for CAN firmware and Survey Touch ready. So Survey Touch is the same thing as Beacon Touch in essence. So it's ready to go to do that. So what we've got so far, we've got our gantry rebuilt. We've got our 4 motors in place. 2 of the motor wires are going to be short, even if we route it down through the front, and there's no real good way of routing it down through the front without printing different mounts. So I believe there are different mounts here that do allow you to run a cable through the mount, but that means we'd be running our cable like right down this side, you can't, you know, the outer edges have panels on them, so you'd have to run that cable down this side, and there's no easy, nice way to do it. My plan was instead to bring them up, run them along the upper channel here, and then down around. Now this piece here can come out, and I realized what those other two wires were for. I had a camera in here that was an ESP32 camera, which was a wireless camera, so all it needed was power. So what that was a 5-volt power source for that camera. The camera did not like the heat too much, and it gave up the ghost really fast, which is sort of why I'm not a big fan of the buddy camera on the Core X or the Core 1, because it is a ESP32 based camera. Now, it could be more heat tolerant, but that is a enclosed chamber. So mileage may vary. It might work. It might die out real fast. I don't know. But it looks like we're going to need some more parts, because, and Evil Diesel, you weren't around here for this, but when we started to take the wires out for the 2 motors, because we've got different wires for the rear motors here that came with the kit, we found out we were going to have an issue. That issue, other than the fact that these are, oh, there it goes. The issue that we're going to run into is the board that is used on this build. This was a DFH kit that we built. It's using a Manta M5P, which is all you really need for a Trident, because you've got 3 Z motors, an A and a B motor. Well, we just added 2 more motors to this build, so we're out of motor slot. So our option is to get, well, I have an octopus, but if I put an octopus in it, now I've got to also put a Raspberry Pi and run separate power and stuff like that. If I go to a Manta M8P, I can take the CB1 that's here, that's already flashed and already working, and have a working base to start from because we're going to have to reconfigure it for the 4 motors. We're going to have to reconfigure it from CNC tap to whatever probe we put in this. We're probably going to have sensorless homing, unless there's provisions for the pod over here, which I'm not feeling, then, well, maybe. There may be provisions for, well, even if we do the pod, then we've got the wiring for said pod. I've got to figure out the X end stop, or at least do wireless homing in the X position. The Y end stop's still here. We still have a valid Y end stop. But I'm not going to lie, a little disappointed that you can't run the AMS2 Pro as a dryer without, exactly. So once again, they came up with some good ideas and nerfed them out of the gate, which, like I said, isn't a showstopper unless you're wanting to change things up, right? Meaning, if you want to tinker, if you want to play, the bamboo ecosystem, I don't think is in your ballywag anymore. Okay, so as you know, we were working towards putting the LGX Pro on here. That changed as well. So the LGX Pro, there's a screw. I dropped something. So the LGX Pro threw me for a loop here, right? Beautiful extruder, great setup, very decently compact, fairly heavy though because there's a lot of metal in here. That's what threw me for a loop. Okay, those are two raised nubs. Don't ask me why there's two raised nubs there, but those two raised nubs prevent me from mounting it to this top plate because this top plate is 100% flat. So we're not putting the LGX Pro on this particular build. We'll try and put it on the, which we should be able to put it on the, whatever build we put the Takata hot end in. What we're going to do, and I've already got it mounted here because I needed to test some things out. We're going to put the FXD extruder on, which makes this the exact same setup that Modbot used for his build. So if you're not familiar, right? Let me hold this up and in place. This is the FXD extruder. That FXD extruder is a full metal dual drive extruder. So, and from what Modbot said, this thing pushes. It pushed so hard that it packed the top of his tube. And in fact, I just put that on there and forgot that the tube, I'll have to take it back off. You're supposed to put thermal paste on top of the tube so that it, you put thermal paste on the tube so that it will help conduct into the metal a little bit better. So I'm going to have to take the 6 bolts back out. I should be able to drop tube maybe at an angle and get it in and out without having to take the fan shroud back off, because that would just suck. Take this out. Try and drop it out so that we can put some thermal paste on here. So there's no filament sensor and there's no tension. It is, we'll say, pre-tensioned. There is no tension setting on it. Get my hand in the way there. So there's 6 screws holding the tube on here. And those 6 screws are M3 by 12. So, and I'm using socket heads because I've got plenty of room. You can use button heads if you want. Like I said, my attempt was to keep all of the screws on here to the same type so that I only had to use one type of driver. However, I don't have 35 millimeter socket head cap screws. Otherwise, I would have done that. And more, I'm going to put my finger under the tube so it doesn't go anywhere. But yeah, on that FXD extruder, it is an extremely constrained path. And I'll show you what I mean by that here in a second. There is enough. So once again, this is a metal chute, the full length up and down. So the filament really has no place to go other than through the 2 gears. and the tolerance is, I guess, correct, so to speak, to give it enough tension from the get-go. So we should be good there. I need to put some thermal paste and slather around here. I'm going to be careful not to get any in the actual PTFE tube area. Got something all over my finger from the top of that. Could have been Loctite or something. Get that cleaned up. Like I said, we'll put a little bit of our MX4 thermal paste on this. I do not know the ratio it's using off the top of my head, Evil Diesel. It's the A3DP, so Advanced 3D Printing. It is their FXD extruder. That is the extruder, and the tube that I won, or not won, that I traded for at Rocky Mountain last year, that I'm just finally getting around to putting in a printer. And I'm going to glove up, and I'm going to put a little bit of this on my finger. And try and just gently smear it on there with my finger versus trying to squirt some on there and then rub it around. Nothing about that sounded kid friendly. Okay. It's not going to be perfect, but like I said, I'm trying to keep away from that PTFE tube. And in fact, do I have a short-ish length PTFE tube? I do. Good enough. What I'm going to do is, as I start to angle this in here, I'm going to put this tube right down. Try and get it right down the throat. That way, that'll protect it from getting anything down in the throat of the Hey, Chewy. How much Z do you lose with the tube? I do not know off the top of my head. I very rarely max the Z out on my printers anyhow, so I'm not that concerned with that part of the equation. We did drop the lead screws down using a set of spacers, and that's going to allow us to still go the full bed area. Normally what would happen is you would lose, I think, up to 17 millimeters at the front, and I still may be losing some just because of the door. But I do have a clicky clack. No, that's a 300 size. It's a 350. So I'd have to get a 350 clicky clack kit from either West 3D or KB 3D, one of the two. Okay, so this PTFE tube is a reverse Bowden tube, so it's not the ideal for use in there. What I really want to do is use a 2mm inside diameter PTFE tube, which I've got a few of them in here, pulled out of other printers. So once again, you would use reverse Bowden to get to the tool head, and then Bowden once you get to the tool head. That way, you have a constrained, once again, maintain a constrained path into your tool head, right? This is down there. Yep, that's down into the top of the tube. What I'm going to do is clean this up. This is obviously one that came out of a printer already. I'll clean this up. I've got to try and figure out how much of a reveal to leave from the top of this. And I'll figure that out based on the bottom of the FXD here. I'll just stick this in there, figure out how much of a reveal I need to leave, which is like 2-3 millimeters. Not much at all. And we'll get this jammed in there. Cut that off. We'll straighten this tip up. Run away. And back down in there. Looking for oh, there it is. Folks. Yeah, so Evil Diesel, that tool head on for the Optimus P1, I basically tore it completely down today while I was sitting in meetings. And yeah, it was a mess. It was a PTFE lined volcano heat break. The PTFE tube in it was cooked. The nozzle itself is just caked full of gunk. Like I'm gonna have to spend days trying to clean it. Good thing I've got a hey, look at that, 3mm. It's a good thing I've got a 06 hardened nozzle, volcano nozzle here that I don't have another hot end for, so we'll put that in there. I'm going to switch it up and switch it over to a titanium heat break with a copper plated, or excuse me, a nickel plated copper heat block, and throw a 65 watt heater in it. So we'll be able to, I don't know, run a, we'll be able to run it at like over 350. Everything in the tool head would be able to go to 400 with a heated chamber and 400. I don't know what might we be able to print with it. Anything we want. Okay, so there's our measurement, and this is the top of the tube, and then into the bottom of the FXD extruder. You know, I just did that, and I don't have the top plate on. So we'll lay that. We'll pull this out. We need to put our top plate on because that's going to add length there as well. The top plate goes on with M3 by 5 or no, M3 by 8 flathead screws. I think I pulled M3 by 6s out. So let me grab some 8s real fast. Ugh. Oh, and Waters, if you're still listening, yeah, there is no way that that tool head had not had a thermal runaway condition in it. Looking at the scorch marks even more after I got the everything torn apart, yeah, it had to have had some extra heat applied to it. What I'm doing is just running these down, and I might have to go back and get these 6s because that's good. See if this one. All right, it was probably put some Loctite on these as well. And then there's a big screw that comes up on the back side of it. Probably should have been put in place before the fans. So I probably will have to take the fan back off. One time. You hate Fusion 360? I'm sorry, bud. Lurking for supper? Okay, Pez Liz. Yeah, it doesn't look that much longer. I could probably, after I find that screw, I've got the stealth burner sitting over here. I could kind of hang the stealth burner up in the same spot and see where it falls. Stealth burner. Stealth burner. Okay, so if we take the stealth burner and line this up, belt path to belt path, it does sit a fair decent amount lower. I mean, that's at least a centimeter. Yeah, I think we are going to be losing some type of a distance there. But once again, we dropped these down as well, so this will now give us clearance. So this is all the way over. We're hitting the motor mount, and then all the way back. You come back here. Oh, we're still hitting this rear I mean, we're hitting it right at this point, and that still hasn't triggered the end stop. So triggering the end stop, this actually bends the Z-axis back some. So we're going to have to look at lowering that a little bit more somehow. At least the rear one, another few millimeters. Like I said, there is a screw that comes up through here, and it's one that I forgot. So if I turn our mount around and I grab that and hide it, you'll notice there's a screw. Zoom in. There's an M5 by 35 screw that does a full compression right there. And I did not put that in yet. So I'm going to have to take my fans back off so I can run that screw in. That'll lock the back side of this plate down so it's nice and rigid. Everything's compressed in there. So 2 steps forward, 2 steps back. That's kind of the way this build's going. So we started to think, oh, we'll work on the wiring. Can't work on the wiring because the wiring requires us to have a different MCU. So I'm going to have to order an MCU to put in there. And it's like, okay, let's work on the Z motors. We bumped out the Z motors. We did remove the wiring that we weren't going to use. Starting to put the tool head together, and of course running into issues here and there on that. Can't navigate Blender, it makes you cry. Yeah, I feel you. Ah, got it. So you're trying to work on fracks. Okay. There's no guide for fracks yet? I would have thought they would have had a guide, but you know, I'm doing takeoff with CAD, and that's why I keep having to get caught. If I was looking at instructions, there would have been something that would have said, hey, don't forget to do this or that at this point, or you'll be taking things back apart. Drop that down. We'll take one of these. Actually, we'll grab a different one. M3 by 35, button head style. And the reason we're going to grab a different one is going through the fans, I didn't want to use the Loctite, but doing this, I will. Put a dab of Loctite on those threads. Figure out where the orifice is. slightly fiddly, made even more so by the fact that you're trying to use, or I'm trying to use uh, a round me over bit. First two lined up and started. That lets us get the rest of our screws in a little bit easier. You guys are good anyhow. You really need to work in Fusion sometimes, especially for some of the projects we're going to wind up doing soon. Especially if we have access to a 600 by 600 by 1000 or 1100 millimeter printer that will be configured to run a 0.6 nozzle to start with, but who knows, may have a 1 or 1.2 millimeter nozzle option down the road. I can find I mean, I know I can get a 1 millimeter hardened nozzle like an Undertaker or something. I think I have a 1 millimeter standard. What I need though is a volcano size 1 millimeter. 100-watt heater will definitely provide enough heat for that melt zone. Hey, Pete, how's it going? Hear me start using inappropriate 4-letter language here. We're building the TakeOff toolhead, which is aptly named because we've taken parts off of it 3 or 4 times now trying to do the build. I was going in, so remember I said that the LGX Pro won't work? The LGX Lite Pro that mounts on this particular plate that I have. Okay, so we've got the base of our extruder here. We need to now put our PTFE tube all the way in. So through that, through the base, into the other base. Why does it feel like it is catching? Because it is. Not lining up. Really, you guys want to play hard to get now? So the fun times. Did not even think about whether or not the hole in the top plate that I just put on the perfect kitty plate. There we go. That helped. It's it's an SLM printed one as well. So you just have to make sure, loosen some things up, make sure you get your PTFE tube down in there. I'm going to measure my 3 millimeter again. So get my 3 millimeter offset on here. And that's 3 millimeters that'll go into the bottom of the extruder mouth down here. I would say that my bed is not level at all. Better. So we'll take this out. We'll cut this length of PTFE tube. We'll stick it back in there, and that'll give us a nice, good, clean filament path all the way through the extruder and the hot end. Well, I say that, and then I shove it down even further, so that's not good. Apparently, I did not have it all the way down in there. So now, hopefully, we'll just take the top mount off and get in there with with our forceps, pull that piece out, throw it away, and we'll try this again. Only this time, we'll make sure that we get it fully down in there. Forceps. Okay. Good thing I have plenty of PTFE tube. And if we remember, we want it just slightly loose to account for any movement inconsistencies. Once we get the PTFE tube cut and down in there, then we'll come back and we'll make it final and right. One that was, and by final and right, I mean we'll fully lock that down. And I think what I'm going to do is I'm just going to lop a section of this off that I know should be too long. Only miss that you needed a center tap. Well, you know, 2 steps forward, 2 steps back. I feel like that's not all the way down in there, and if I cut it again, I'll be in the same position I was the last time. I think that's about as far down as I'm going to get it. Guess I can try and take yep, far down as I'm going to get it. We'll double check against the other one before we cut. So if it's quote unquote the same length, then we won't cut it. We'll have to figure that back out again. Now we jam that back down there. I'm going to grab it with my forceps at the top. which is no big deal because we're going to cut that off anyhow. That still doesn't look like it's down there long enough. What do I do with that piece that I threw it in here? Oh, yeah. Don't mind me as I go dumpster diving real fast for the piece of PTFE tube that I cut earlier that I've now apparently, it wasn't that one. Evil Diesel, why'd you let me do that? I don't know. That looks, once again, like it's going to be too small. So that won't go down in there. Well, this, how far down will bottoms out? This will bottom out. Does, but if I grab the two, this is how we mark, and we'll double check. We'll 3 millimeters up. That's 2 millimeter driver, so it's going to be too thick to go down into the actual tube, but it's going to give me a good idea of what the length should be. Actually, it's going to give me the length that it should be. And I would have been like half the length that it needs to be. Okay. Try this. It is obviously getting stuck somewhere. Tighten those. Fine. What is? Once I get this path in, it'll be fine, but you gotta get this path line up. Hey, Westery, how's it going, sis? Yeah, there's a part of me that wonders if I need to. Nope. So I'm wondering if I've just got too much in the path is kind of, it seems convoluted. We're going through multiple parts, and some of these parts are, well, they're 3D printed, and I did not even think about, hey, like, might be a good idea to run a 4 millimeter, um, not a drill, but a 4 millimeter reamer through it, because then your PTFE tube goes through very smoothly, especially if all of the 4 millimeter parts are lined up. So what I should have done was off everything, mounted these two plates, and then drilled them or reamed them to make sure that that 4 millimeter shaft is aligned, is basically what I'm trying to say. So what happens when you don't do that ahead of time and you mount everything? Well, you unmount whatever you can, you put a towel down, and then you basically do it in place. So what I'm going to do is remove the fans, remove the tube. We definitely do not want to do it with the tube in place, and put metal shavings down in our $200+ hot end. That'll make the dragon cry. Drop that out. We're going to have to take rear screw out. Take the top plate entirely off. Please come out. We might be cutting another link. That one's worked a bit. Put that to length. We take the tube back out yet again, and then I'll put the top plate back on, get it lined up. I'll put a paper towel down, and I'll ream right down through the throat of the top plate and this riser here, and that should give me a cleaner 4 millimeter path all the way through for the PTFE tube to go through, because it's just friction, and it's ever so slight misalignment between parts that will cause that PTFE tube. I mean, it shouldn't be too tight that you wouldn't be able to get your filament through cleanly. But you also don't want a lot of wiggle room for your filament either, because that will lead to other issues. Like, preferably, if I had a 2.5 millimeter inside diameter, that might not be bad, but 2 is fine. If your filament is that oversized, you've got different issues. You need to just find a different filament vendor like Polymaker or EPAX or CookieCAD or Polar or somebody else that's reputable. Okay, so that's out. We'll set that to the side. I'm going to get some paper towel before I forget. We'll lay paper towel up here over all of that stuff. Right? Make sure we don't get anything there. Do need my top plate. .5. I have those two. Got the rear one that we know is a joy. Get in place. That one, this one, this one. Now, once again, we're now set up. We'll need our drill and we want our reamers, not our drill bit. The drill bit will bite in and you could drill it off center with our straight reamer bits here. We will be able to keep everything nice and aligned and ream right down the length and bring everything into spec. Because the reamer's not going to walk. You do it like this. So I'm going to get this set right in there. And I'm just going to go bzz. Okay, and just like that, didn't take very much off, but there is a little bit on the towel. So that shows that we did get some material out of the way there, which should make it easier for our PTFE tube to go in. Because once again, with as much as I was having to push on that PTFE tube, even if I did get it to go down and fully seat, chances are I would have put some type of kink in it and caused us problems down the way. I don't know why I didn't have that on full bench view for you guys. Sorry, but there is some metal shavings in there. We'll bring those over here to the garbage can. Set aside for later use doing something, not wiping down a critical surface, of course. So I've got this on here. We need to take that back off so that we can put our tube back in. Have access to the bolts for tube. How you doing, Westery? I was showing off those printer parts that I was talking to you about last night. That's going to be a fun project. And I think the majority of it was in here. Okay, we need one of these again. Cleaning house, staying in. Well, that's good. So eventually, when we get this printer put back together, of which tonight we found out we're going to have some more work to do on it because this has a Manta M5P on it, which was fully, it had the 3Z motors and the A and B motor, and we just added 2 more motors, so we don't have enough stepper drivers. And you can get around that by adding another board. You might be able to get around it by using, oh, I didn't think about that. Isn't there a Big Tree Tech like stepper extender type thing where you can add a couple of motors? So that would be an option. But I think what I'm going to do is order a Manta M8P, and we'll do a brain swap. The nice thing with doing a Manta M8P is I can just move the CB1 module that's currently running this printer over to the other board, and that will give me a good starting point to start from because we had a known working config. We'll just have to go and comment out some old stuff, add in some new stuff. We'll be able to go on our merry way. Okay, those are back on. Where's my perfect top plate? Now, when you get this, this is SLM, so centered laser metal, I think is what it is, manufacturing. You're building, it's like resin printing with metal. The best way to think about it. You're building up your layers one at a time, and you can have some stuff that's not as straight, right? Like, we have to ream our 3D printed parts occasionally. Well, that's basically what we just had to do is ream our metal printed part instead of our plastic printed part. Right? Okay, so now here's that little piece of PTFE tube. I want to see, oh look, see how easily that went down in there? Nice. Now I'm not going to get it back out very easily. I have to use my things again because I don't want to use this because I did yank it out that way before, so I have messed up the wall of this one, but we'll go through and cut a new one to the same length. Twice. Now watch. All the way down in there. Now we can take this, line up. This is a CNC milled product, so it's going to have tighter tolerances. Be able to screw this down. And hopefully by the end of the night, we'll at least have a something that looks like a complete tool head on here. We won't have any of the wiring done, so we'll still need to do that. What I'm going to do is look at and see if the Voron board has the provision to run different voltage fans. If it does, since I'm going to have to order a board anyhow, maybe I'll order one of those as well. Because why not? fans lined up for the 4th or 5th time tonight. But kind of one of the places I was going earlier in the conversation was these parts needed to be tapped, right? There's holes here for various mounting methodologies, and you can pay to have them tap, and they will tap all the holes so that you have all the options. I chose to tap it myself, so that saves you some money, but then you have to go through and look at the CAD to figure out, okay, which holes do I need to, do I actually need to put taps in, or should I just go and tap them all? And at first you go, oh, I'm going to go and tap them all, until you start tapping them and you're like, yeah, maybe not. Right? That's 3 times trying to organize space. Gotcha. You're able to tap it with 2.5, so you're good. Good. So did you not have a 3 mil tap, or? Yeah. Still need to cut those rods. Material's sitting outside. I just didn't get to it last night because I drove in to evocate and played around with the Optimus P1. Like I said, I think stage 1 is getting it working. So doing the hot end stuff, yeah, I'm putting in the standard thermistor, and I'm having a PT1000 come in as well, because what will happen initially is we'll just use the standard thermistor because I know that works with their firmware. Then what I'll do is come back in later on and, by the way, love CNC tooling, Mark. Love seeing that. So this basically slides in. These 2 little areas down here are keyed. So it has to slide in from the top to lock in with a part, like so. Things keep moving around on me. And then this is all metal gears. And there's a part of me that wants to put some grease on it, but we got to be careful that we don't get said grease also in the filament feed path. So I'm going to very lightly put a little bit of grease in here, not a lot, just a little, and we'll run the gears around. And I'm doing a very, very tiny, small bead, because I want it to be on the drive gears and not on the filament path gears down here. So very, very tiny bead. Just reduce any chance for, well, not reduce, chance for, but try and get some chatter out. I'll do the same thing on this other gear, which is going to be both on the big gear, and then the big side here goes on the motor drive gear. So just a little bit. We're not trying to put a ton in here. Very tiny bead. Few drops basically. I think this is basically like what we were doing with the N20 motors on the Box Turtle. Right, we're just putting a little bit of grease on there to quieten down the gear train without actually impeding anything. Now comes the fun part, and that's because we already have this mounted, we have to have these 4 screws mounted before this goes on. Got to tilt this in on the PTFE tube. Actually, let me go ahead and put the back on and all the pegs up like that. There's all of our pegs lined back up. Now I should be able to set this straight down on there. Get it sitting down on the PTFE tube. Be a little bit too high on the PTFE. Not getting full on sides. Wondering if PTFE tube. Might be a smidge too high. Did that okay? PTFE tube is just a smidge too high. If it's not one thing, it's another. And I'm not going to get that PTFE tube out. So I'm going to say, do not do this at home, folks. Because I am probably guarantee you right now that I am not making this a 90-degree angle slice, but going to be close enough. And I just took the tiniest sliver out. Focus. So the tiniest sliver out, and we'll see if that gets our piece down on there. And our holes lined up. There we go. Boom. So we've got, I need my motor. And we're going to run the motor with the cable up. That way we can join it with whatever gear slightly, or am I just spur gear might be just is the motor they said to buy for this. We'll try and put it on there and see what happens. Line things up, drop it down, put this much. So this screw that I'm using came with the extruder. One there, one at the bottom. There will be one at the top right. Go. You have 2.5, 4. Right, see that's binding. Binding on the spur gear. So I wonder, first you don't succeed. Okay, that was the Bondtech extruder motor. What if, that's going to be way too long. For love and hay. Yeah, I probably should have looked at how deep those were, because I'm going to need at least one more screw. And those were shoulder bolts. Definitely more than 12. 18. Getting us there. Is that not an M3? Could be. Jesus. I'm telling you, not one thing, it's another. Long enough. So 18, so I need a 20. in the ever-loving screw goes in. Screw does fit. Use the right size driver for the screw, and I bet you that screw will go in a lot easier when you use the right size driver. So the bottom ones use a 2mm driver, I think. Yep, they use a 2. And the top uses a 2.5. And why are you not lining? You work with me. So what I'm doing right here is snugging. Okay, and everything is moving, so that's good. I think maybe I just had this snug down too much. Okay. 2.5. We used the Bondtech motor, hooray. Hooray, hooray, hooray. Grab the Bondtech sticker and put it out here so that we can add it, because why not? That was more painful than it should have been. Hey, look, we have TakeOff. To a degree. We still need to figure out a cartographer, so either cartographer goes on there, or I'm going to need an appropriate H, which would be the 90-degree and not the flat, which is the H that I have is the flat to go on the VZ bot. So we need a cartographer and we need a whatchamacallit? Words on string. We need a cartographer and we need, or a beacon, and we need a Manta M8B. So let's see what we can do here real fast. Let's take a look at some, put away the grease and the forceps. And let's take a look, let's do some shopping. Let's put you over here on full display. We'll come over here to this. At this point, I cannot really do anything more on the printer. So let's do the right thing. Set this down on the ground and get it out of the way. That way we can put keyboard over here. Put the motor wires over there, of which, like I said, I'm most likely going to have to redo those motor wires so that they're longer for the front motors. I don't know if, like I said, that kit was designed for a 250 or what, but it's not fitting on a 350. We did those. Still have an issue. We might have to redo one of these, and I'll see if I can't make it a little bit taller. That, don't need that. So, what is it? Hoovid board? Oh, there we go. HUVED. What I just want to see is, will the Hoovid actually work? Evil Diesel works better without the E at the end, unless you were trying to say Luke. Bum, bum, bum. This is a CAN bus board. I do see potential jumperage up here. So one TMC 2209 for the extruder, 2 MOSFETs for fans, one big MOSFET for the hot end heater, thermistor input, port for an in-stop or filament runout sensor, M32F103, USB for flashing, main power is 12 to 24 volt, 24 volt is preferred. Keep the currents low. Got mountain hookup and signal ground 3 pin or 3.3. That's in stop thermistor fan 1, fan 0, fan 1, hot end, stepper driver. And it does not look like there is yeah, this would require the fans to be the same voltage. Okay. So what I'll wind up doing is, because we don't have a hot end cooling fan, we're just having the parts cooling fan. This is an air cooled, so there's no hot end fan needed. What we're going to do is we'll run CAN bus cable. We'll have the USB cable, or if we're running if we can get Cartographer, let me look up Cartographer. So Hoovid's not going to get it for us. Cartographer. Cartographer 3D probe. Really? Batting 8,000. Cartographer V3. Back in. Right, so not a lot. Not a lot of options. Let's see, who's selling? Watts Kraken. Siboor, but only sold with printer kit. All right, so Watts Kraken is the only option for it. Never ordered from. Will be through shaping. And they don't. Okay. So if we do beacon, beacon is USB only, and I believe it is. Beacon Rev H. Rico has it. I don't know why. I don't know if KB3D has. Nope. Nope. So KB3D doesn't have it. Did see that Fabrico carries them. Oof. Yeah. Standard and low profile. I think that's the low profile, and I really need standard for this. Remember, right? TakeOff. Beacon Rev H, SLM ducts will not work. Rev D. Okay. Rev H. Does not say. Does not say which version, but looking at this is the 90-degree stand-up version that shows there. That's the low profile one. They have it. It might work, but we would be so another option that I may have. All right, anybody out there have anybody out there have suggestions for getting a cartographer quickly? And is there an option? Yeah, I was looking at that and saying, okay, what if I mount that board up underneath, but then it's probably sticking down too low. The idea with the cartographer, at least if I use the cartographer, then it would be if I use the cartographer, I could do an additional CAN bus because it is CAN bus or USB. With the beacon, it is USB only. Means another wire that's going all the way to the back through the back panel somehow. I don't know. So who all is still with me? See a few of you in here. Sure. Well, I'm trying to think, Evil Diesel, because Fabrico has the beacon, but it's the wrong version. I need the standard, which is the 90-degree version. Right, so that's the standard, normal. This is the version that I need. I don't think the cartographer will work, but they're out of the standard. Um, oh, does West 3D have it? West 3D has it. Well, that may be what it is, because I don't want to take it out of something else. You got it from West 3D a week or so ago? Yeah. What I want to do though is see, like, well, I guess bu- 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 yeah. I think what I'll do is I'll double check and make sure that normal, well, the CAD shows normal, right? So there you go. We'll get normal. Um, do they have the Manta M8P? They do. So here's the thing: is I was thinking, well, hey, what if I do? Oh, thanks for the lurk, West 31. I was thinking, what if I, just do an octopus board, because I have an octopus board here. Couple of things. It's currently got a CB1 and a touchscreen, which means that touchscreen works with the CB1, because the CB1s can't work with the normal touchscreens, right? They can't work with the DSi touchscreen. So if I get a Manta M8P that gives me the 8 drivers that I need, or 7 drivers that I need, I can still use the CB1, pop it off one board, slap it on the other, flash firmware, boom, we're done, and have at least an initial working config that I just need to tweak a little bit. Um, Also, if I do that, I keep the print history, which at least is the amount of print time that I've got on that printer overall. Now, the other thing is that has a UHP 200 on it, and there we go. It currently has a UHP 200, and adding that Chube, I have a 100-watt heater in the Chube. But luckily, I have a UHP 350-24 sitting here, so I don't need another one of these, because I was looking for one of these the other day, and for whatever reason, they got more expensive. Everybody's listing them with whatchamacallit, tariffs built in. So, okay, so we've got Victory Tech board, a beacon board, normal. Okay. Shit, while they're at it, is there anything else I need? How about I need to use my own code? Yeah. Oh yeah. I'll use my own. Huh? Okay, well that didn't work. What else were we talking about? We needed a beacon probe. We need a beacon probe and a M8B. We're going to use the CB1. Pretty much all we need, right? I'm going to do some shenanigans with the CAN bus cable that's in there. I'm just going to cut it up and repin it. But I also need to figure out, I cannot run that cable gland because the Siboor kit does not have a provision for CAN bus cable gland. So we're going to have to run it through the back panel like I've done on several of my other machines, which isn't that big of a deal. We've got the EBB42 that will run on the back of the extruder motor. And the yeah, I think that's kind of where we're at. I think we're pretty close. Well, we're not pretty close to being done. We've got a long way to go still. But yeah, I think what I'm going to do is, one, we're going to call the stream. Two, I'm going to order some parts. See if I can't throw a note in there to say, hey, can you get this here to me like it was tomorrow? Probably not. I don't really need it that fast. I have two other projects that we can work on. It's just, I'd love to get this one done and buttoned back up. But better safe than sorry. We're going to have some work to do on here anyhow. I'm going to need to, I guess, just see if there's anything else I need while I'm at it. Maybe buy some more ambrosia. But yeah, I know that, like, Nighthawk isn't a bad option, but there isn't like a Nighthawk. There's a stealth burner version and a 36 board, right? There's not one designed for a standard NEMA 17, right? I don't think so. Yeah, they're only showing the stealth burner and the 36. And I wouldn't want to do just the 36 on here. Yeah. So we'll go with the big Tree Tech board that I have. We'll have to get that flashed and everything going there. I've got to figure something out with the motor wires. I think I have some longer motor wires already on hand. And if I do, I can repin them with the, I've got the locking Microfit 3 connectors. So I can do that. I would much rather just use long cables than try and splice some cables together for this. So But yeah, I think we'll be good there. So I'll go grab the payment method and get that going. And like I said, I think we're going to be done for the day. Let me see who's up and running that we can raid out to. Who do we got? Who do we got? Cyber Jewels. Declaration. No idea what. Good enough painting. Looks like he's doing some painting. First playing games. Science is out there. Jano's up and running. Go take a look at Jano and see what Jano's up to. It looks like he may have been cutting hair or something. So I've got a raid for Big Jano started. Folks, please come on with me as we go over and raid Big Jano. Thank you for being here and listening to me ramble on a little bit about the various other projects that I have. Looks like we're going to be working on one of those sooner rather than later, as we wait for parts on the Trident 350. But thank you all for being here. I really appreciate you guys being here as I dig through this and see me troubleshooting my brain, which is kind of an ugly thing. But yeah, thanks for being here. I will see you guys on Thursday. You guys stay safe between now and then and have a great day. Bye now. For those of you watching this later on YouTube, thank you for being here and taking the time. I know I kind of have some longer streams here and there. If you like what you see, please go ahead and click the like and subscribe button down below. Be sure to click that bell to make sure you're notified of new videos. YouTube is going to suggest another video over here.